Hello, I'm Maria Williams with the Collaborative on Health and the Environment. Jay enjoys bringing you the latest environmental health science through our partnership calls and webinars, news feeds, publications, and social media. I would like to welcome everyone to today's Jay Partnership webinar, which is titled Regrettable Replacements, the Next Generation of Endocrine Disrupting Chemicals. Our moderator today is Richard Clapp, Professor Emeritus of Environmental Health at the Boston University School of Public Health and Adjunct Professor at the University of Massachusetts at Lowell. We will leave time following the presentations for a brief Q&A session. You may type in questions through the Q&A feature available on the menu bar at the top of your window at any point during the presentations. After the presentations, our moderator will read out questions for our panelists to respond to. We will get to as many comments and questions as we can during the Q&A period. For those of you who called in on the phone, we have posted slides to accompany today's webinar on our website. You can download these by going to healthandenvironment.org. Please scroll to the bottom of the page and select today's webinar. On the webinar page is a link to the slides. Everyone on the webinar right now is muted with the exception of our moderator and our speakers. This webinar is scheduled to last for 45 minutes and is being recorded for our call and webinar archive. With that, I'll turn things over to you, Dick.
Thanks, Maria. It's a pleasure for me to be a moderator for this. This is the second in a series of the webinars that are called 20 Pioneers Under 40 in Environmental Public Health. And so these two scientists are the next two in this generation of up-and-coming stars, I would say. The topic today is something that really parallels what's happened in workplace exposures, where the term comes from, or there's a hierarchy of controls for workplace exposures. And the first thing on the list of hierarchy, of the hierarchy is substitution. In other words, if there's something that's harmful, a chemical, let's say, is a harmful chemical that workers are exposed to, the first goal for an industrial hygienist is to try to find a substitute or recommend a substitute. And sometimes those substitutes are actually no better than the chemical that they were replacing. I personally had the experience of knowing a worker who died from exposure to what was called a safe solvent at the General Electric plant in Lynn, Massachusetts. It was a substitute for something that actually was probably worse, but the substitute killed him as well. And so what we're talking about today is the sort of equivalent in the general environment or the home environment of some chemicals that have had some regrettable replacements proposed and used for them. Some of the same ground was covered in the first seminar in this series, and both speakers in the first seminar 2 weeks ago mentioned one of the compounds that will be talked about today, chlorinated tris. But the two speakers today are first a Tufts graduate named Laura Vandenberg, who is one of the 20 young scientists under 40, who now works as an assistant professor and graduate program director at UMass School of Public Health and Health Sciences in Amherst, Mass. She did her doctoral training at Tufts University School of Medicine and postdoctoral work at both Tufts and Harvard School of Dental Medicine. And she's focused especially on endocrine disrupting chemicals in early life and early life exposures that lead to developmental problems and diseases later in life. She'll talk about some lessons learned from her work with what was supposed to be a less harmful alternative to bisphenol A. And the second speaker will be Courtney Carignan, who is now an assistant professor in food science and human nutrition, pharmacology, and toxicology at Michigan State University. Courtney did her doctoral training at Boston University School of Public Health, and then did postdoctoral work at Dartmouth, and then at Harvard School of Public Health. And she's focused on exposure assessment and biological monitoring and human health effects of halogenated flame retardants. And she will talk about some of the findings from this work. So I'd first like to give the podium, so to speak, over to Laura. Take it away.
Thank you, Dick. It's great to be here with all of you who are on the phone and watching this webinar, or even people who are going to watch it in the future from taped versions. I do recommend that if you're on the phone, I'm going to show you some videos, so you won't be able to see them by just looking at the slides. So hopefully you can access the video at some point in the future. I'm going to talk today about some work that we're doing where we're interested in not just the exposed offspring, which has been my focus for a long time, but also looking at the effects of chemicals on the mother. So all children are now being born pre-polluted. And I know this is a provocative statement, but exposure scientists have revealed that there are hundreds of chemicals found in the bodies of newborns, found in their blood, in amniotic fluid, in placenta, in tissue from the umbilical cord. And really, our knowledge is limited to looking at select chemicals that we know to look for. Of course, the concern is that children are being exposed to many more chemicals that we just don't even know to go looking for in their bodies. And for many years, as odd as it might seem now to think back on it, the womb was thought to be a protected place, almost like a fortress. And it was thought that mom could do as she pleased, and that the offspring wouldn't be affected. The noted endocrinologist Howard Byrne gave the term the fragile fetus, which notes that a fetus is exposed to alcohol, some drugs like diethylstilbestrol, or other drugs like thalidomide, and hormones would be affected by those exposures in the womb. So this is now an acknowledged part of the fields of developmental toxicology, as well as endocrinology and pharmacology, that what happens to us during early development can permanently shape us in ways that are very clear when we're born, or could be entirely unclear when we're born and will manifest later in life. So it's well known that developing individuals are sensitive to estrogens, but is the mother? And this is the sort of new way or the new direction that a lot of my research is going. And this is a beautiful figure from Andrea Gore and Cheryl Walker, which illustrates the idea that, of course, we know that environmental chemicals can directly affect the pups' brains, other physiological endpoints in the pups. But endocrine active compounds or endocrine disruptors could also be affecting the mother, and that this would change how the mother acts. It could change how much the mother lactates. It could change the transfer of nutrients to the pups. And so effects that we see on the pups could be due to changes that are mediated via the mother. So I'm asking, is pregnancy a period of development? We think about the fetus as the developed creature, but is the mother also developing during pregnancy and lactation? And if she is, then we might expect to see that certain endpoints are very sensitive to hormonally active compounds, and including lactation, maternal behavior, and other endpoints in the mom. And for many years, it was assumed that estrogenic chemicals just couldn't have an effect on the adult, and in particular, that these chemicals would not affect the mother during pregnancy. And the reason why is that serum hormone concentrations are high during pregnancy. Shown here is, of course, human pregnancy, where both estrogen and progesterone go up significantly over the period of pregnancy. And this is also true for the rodent. So to address the question of whether mom is being affected by environmental chemicals, we've been taking pregnant mice and exposing them throughout pregnancy and the lactational period. We've trained them to eat a little tiny cracker that's dosed with our chemicals of interest. And of course, we're interested in her pups and the outcomes that are seen in the pups, but we're also interested in the mom herself. So we've been observing maternal behavior in the mothers on lactational day 2, 7, and 14. These represent periods of time where the pup's needs are very high, then moderate, and then start to be lessened right before the pups can feed themselves. And then we collect maternal samples from these females at the period of weaning, when we also can collect samples from their offspring. Now, the chemical that has received a lot of attention by scientists in numerous fields, as well as public health advocates, consumer advocates, is BPA. And we now know that BPA is used in a lot more products than was originally understood. It was originally thought to be something used in plastics, and then it became known to be used in epoxy resins that line food. And now we know it's also in medical and dental equipment, in thermal papers that are used both as receipts and as food contact papers, and also in other consumer products, including cigarette filters. And again, in the last few years, it's become very clear that as consumers have requested BPA-free products, that a lot of those products have hit the market and they look and feel very similar to the original BPA-containing products, and they're splashed with the label BPA-free. And we're starting to see that what's replacing BPA are a lot of other chemicals with similar chemical structures, including many other bisphenols, several of which are noted here. So BPA really was the tip of the iceberg when it's now being replaced by, in some cases, there are, people estimate 20 to 50 replacement chemicals now for BPA. And the chemical that I focused on is shown here on the left is BPA, and on the right is bisphenol S, or BPS. And BPS has been detected in canned foods. It's used in consumer plastics. It's been measured in some personal care products, and it seems to be the biggest replacement for BPA in thermal paper. So it's commonly found in receipt papers. So our first question, of course, here's a beautiful human baby, but we use the mouse as our model. We've been asking, does BPS alter milk production in the mothers, the mice that are exposed during pregnancy and lactation? And this is a study that was just published in the journal Endocrinology. And when we look at the whole mammary gland, so this is the whole mouse mammary gland that's been stained and put on a slide, we can see that while the control mammary gland looks like a very thick carpet, the BPS treated mammary gland, you can actually see through those tissues. So it's less dense. And when we quantify this at the single, at the level of tissues that have been sliced to look at them one cell thick, you can see that in the control, there's a lot of very dense purple areas. This is the actual functional part of the mammary gland, versus in the BPS treated animals, there's a lot of bare empty spaces. That's the fat in this animal. So there's less actual functional tissue in the females that were exposed to BPS during pregnancy and lactation. And there do seem to be effects that are observed on the offspring. So pups that have been exposed, that are born and raised by these mothers, are more likely to still have their eyes closed on postnatal day 14. So mice pups are like puppies or kittens. They're born with their eyes closed. And most mice should have their eyes open on postnatal day 14, and that's not the case with BPS treatment. And those pups also are less interested in initiating nursing from their mothers, perhaps because they're having trouble locating their mothers. Our second question is, does BPS exposure alter aspects of maternal care? So what we see is that there are many aspects of maternal care. One is how much time does mom spend on the nest with her babies. And moms should spend a lot of time early in lactation, lactational day 2, not just because the pups need to feed often, but because they're incapable of keeping themselves warm. And you can see from the white bars shown here that over time, control moms spend less time on the nest as their pups become more capable of caring for themselves. And that doesn't seem to happen in the BPS treated animals. And while at first glance that might seem like BPS treated animals are better mothers, they're spending more time with their babies, we think this is actually indicative of that lactational problem. So they have to spend more time with their pups because they can't lactate as well. They're not producing as much milk. We also look at what happens during a pup retrieval test. In this case, everyone's removed from the cage. The pups are scattered throughout the cage, and we observe how much time does it take for the mom to interact with the pups and return them to the nest. And controls are generally very good at doing this. And you can see on the right side of the slide at the top, this is a mom who has retrieved her pups to the nest and also started to cover them. She's hiding them from me. Versus at the bottom right, you can see that this mother has left her pups scattered and has destroyed her nest. And so this is a sign of poorer maternal care. The daughters that are exposed in the womb, interestingly enough, also have disrupted maternal behaviors. And these start as early as lactational day 2. So we're now talking about females that were exposed themselves only during gestation and the first 20 days of life. And then they're grown up to be adults and mated to control animals. And they are poor mothers. So they don't spend as much time on the nest. They don't spend as much time nursing or caring for their pups. And some of the disruptions that we actually see that these BPS exposed daughters, their treatment of their own pups can be quite severe. In some cases, we see infanticide or severe neglect, and also pups that mom just fails to clean and that she sort of stomps and bruises. So I am going to show this video to you, and I'm warning you that for those of you who aren't used to looking at mouse behavior, it is a little bit disturbing. This is a BPA exposed, BPS exposed female. She was exposed during early development. And you can see we haven't done anything to this cage. She has failed to gather her pups. So they're not on the nest, they're not gathered together, and she's literally stomping these pups to death. After the pups die, which these are 1-day-old pups, and at some point during this day they would die. In this example, we euthanize them, but if she does this at a time that we're not present, she will consume the pups also, so to commit infanticide. For researchers who study infanticide, this is quite different than what's usually seen. This is not aggression towards the pups, which is typical of mouse infanticide. It's instead that the mother herself is displaying what looks like obsessive compulsive or hyperactive behaviors, and she's just incapable of caring for them. So our last question is, do other xenoestrogens alter aspects of maternal health? And we've been studying ethinyl estradiol, which is considered the positive control for estrogenic activity. It's the estrogen that's found in pharmaceutical birth control. And we did not see effects of ethinyl estradiol on the time they spend with their pups, on the development of lactation in their mammary glands. We did not see infanticide in ethinyl estradiol exposed mothers, but we did see this interesting behavior. So the pups are located at the back of the cage, and the mother is going to repeatedly retrieve her tail to the cage. You're going to see her do the same thing over and over. She's like a little ballerina, and she's going to do this little twirl and retrieve her tail to the cage. The mothers who display this behavior do it for a large percentage of their time, and they each have their own sort of OCD-like way of doing it. So she has a double twirl that she does. Other females would have a little bit of tail biting or a flip maybe in the middle. So each female has her own unique OCD-like behavior. And I think it's important to point out that recent research from epidemiologists have suggested that there is obsessive compulsive disorder that's observed in the postpartum period in about 10% of women. It's also observed in some fathers, and this is unique to the postpartum period, and it usually corrects itself within 6 months after giving birth, but it's an important part of care for women, and we don't really understand its etiology. So why does this matter? We know that in the rodent, at least, good behavior begets good behavior. So good moms that raise their pups in good ways have daughters who become good mothers. And bad mothers who don't take care of their pups their offspring become mothers who are also bad mothers. We also know that women's ability to lactate is important, and that somewhere near 80% of women will experience a problem initiating or maintaining breastfeeding. These are women who want to breastfeed and experience problems with it. And there are many reasons, there's many health benefits from breastfeeding, including some where we're reducing pediatric diseases and some pretty severe pediatric diseases by promoting breastfeeding. So some of the take-home messages: the mother isn't merely a vessel. In toxicology studies, we have often treated the fetus or the offspring as the creatures that we care about the most, when in fact mom is also being affected by these chemicals. And in many ways, we have not used the tools that we have available to study mom carefully. And I think it's become clear to me that BPS is a regrettable substitution. We often hear that we're choosing between the devil you know and the devil you don't. We know that BPA is bad, but at least we know what it does. So should we keep using BPA, or should we replace it with something else? And I think that this is going to be a challenge for decision makers about what does it mean to create a replacement. And as Dick was saying in his introduction, if the replacement is as bad as the beginning thing that you were trying to replace, or causes different levels of harm, that's sort of not the point. I also think that effects that disrupt the mother become unsustainable, and that there's a Native American principle of the 7th generation principle, that in every decision we make, we must consider how it will affect descendants 7 generations into the future. And as environmental health scientists, that can be a difficult thing to do when we're trying to solve problems that are here now, but the solutions, in my opinion, should be sustainable for 7 generations in the future. So I'm gonna just end by showing you a very cute picture of the people who work for me, and to note that this is work that was funded by NIEHS, and a lot of the work that I talked about today was done by my former PhD student, Mary Catanese, and an undergraduate in my lab, Charlotte LaPlante.
Very nice, and very nice picture to end with. So we're running a little bit behind schedule, so I'm going to quickly ask Courtney to start and present her slides, and then we'll have hopefully some time for Q&A at the end.
Great.
So I'm very honored to be here today to talk to you about work I've done looking at replacement flame retardants. So flame retardants, there you go. Flame retardants are chemicals that are added to products to help reduce their flammability. So they are or have been added to all the products shown in this picture here. They are additive, so they're not chemically bound, so they easily escape these products, get into the air and dust of our indoor environments, and get into our bodies. I like to think of them as kind of sticky, so they kind of stick to your hands, and we all ingest a little bit of dust every day. This is particularly important for toddlers, young children that are crawling around on the floor, doing a lot of mouthing behaviors, which is part of their normal development. This results in higher exposure to flame retardants in children ages 1 to 5. We also can see higher exposures among infants because of some of these flame retardants are lipophilic, and so they're excreted preferentially through breast milk. The polybrominated diphenyl ethers, or PBDEs, are flame retardants that were used for several decades. They've been shown in animal and human studies to alter thyroid hormone, alter neural development, and also to alter reproduction. The PBDEs, including the mixture penta-BDE, which is used primarily in polyurethane foam, such as that used in upholstered furniture, was phased out in 2005. And with the phase out of penta-BDE and the PBDs in general, we saw an increase in use of replacements. So in foam, that would be TDCI-PP, or chlorinated tris, which is an organophosphate flame retardant, and also the Firemaster 550 mixture, which is a mixture of organophosphate and brominated flame retardants. So in my dissertation work at Bosch University, which wrapped up about 4 years ago, I characterized human exposure to flame retardants with a focus on some of the replacements, looking at 3 vulnerable populations: nursing mothers, office workers, and collegiate gymnasts. And in nursing mothers, I looked at the replacements for DECA BDE, which is used in the plastic casings of electronics, HBCD, and TBBPA. So they're also used in other products, but they can also be replacements in the plastic casing of electronics. Okay, so one of the main findings from that study was this association between the levels of HBCD in breast milk and the number of stereo and video electronics in the home. So we found that mothers who had 7 or more of these electronic items had average concentrations that were 153% higher than those who had 4 or fewer, which is consistent with the reported use of HBCD in these products. Following publication of that paper, EPA had issued an alternatives assessment for HBCD and issued a significant new use rule for it. So this was through the Design for Environment program, which is now Safer Choice. And there might be some folks on the call who can comment more on the current status or future status of that program. I also looked at the urinary metabolite of TDC-IPP, or chlorinated tris, which is BDC-IPP. And this was detected in 100% of the urine samples. I should have noted that HBCD was also detected in most of our breast milk samples. I think it was 100 or close to 100%. And I used linear regression to evaluate associations with demographic, dietary, and behavioral characteristics, similar to what I did with the HBCD study. So I found 2 main predictors. One was the office building. So workers in building A, which was a newer building, had concentrations that were lower than workers in buildings B or other. So this is on the, well, anyways, I'm not gonna tell you where it was, but one of those is my building. And this indicates that the office environment is a source of exposure. We also found that workers who reported washing their hands more frequently, which is shown in the darker color there, had lower urinary metabolite than those who wash their hands less frequently. And for those who wash their hands less frequently, this was dependent on the level in office dust. So if the office dust had higher concentrations of TDC-IPP, we saw higher concentrations of the metabolite in their urine. So this suggests that hand washing, in addition to being a good public health intervention in terms of preventing the flu, for example, can also help reduce exposure to flame retardants. And this also was sort of consistent with the call at the time, which was to maintain fire safety without the use of flame retardants, which I think Arlene Bloom might have coined that term and did a lot of work to get the standards changed for that purpose. So the revised TB 117 fire code was for residential furniture and did not apply to Boston furniture. So in offices in the Boston area had more stringent fire codes. And there was a group in Boston, including Silent Spring and some others, that worked really hard to get that fire code changed so that we can maintain fire safety without the use of flame retardants in office buildings as well. So as a former gymnast, when I was doing this work, I knew that there's a lot of polyurethane foam in gymnastic safety equipment. And I was concerned that flame retardants may be used in that foam. And so I did some sampling, ended up doing a study where I did indeed find high concentrations of flame retardants in the foam of the loose foam pit. We also found flame retardants in the landing mats, so all these like mats you see around the gym, and measured high concentrations in the air and dust. So I'm going to show that data in a minute, but first I just wanted to highlight that. So the foam pit is used by gymnasts to learn new skills safely. It's very important in preventing injury. It's also used by younger gymnasts in particular to have fun. So this is some pictures I found on the internet of kids doing just that. So it's fun to play in the pit, but it's also a really, it's full of flame retardants. So we found that concentrations in dust were 200% higher in the gym compared to residences. So here on the left are a level in the gym, and here on the right is a level in office. In the residence. And then in air, they were 400 times higher in the gym compared to residences. And we found higher concentrations in air near the foam pit compared to away from the foam pit. And these results have been replicated in a second study by LaGuardia et al. And so in the background here, you can see the foam, and you can see that the foam itself actually it photodegrades, and so it turns into this dust. Gymnasts call it pit dust. And when you land in the foam pit, you come out and you have this film of pit dust on your skin. And the dust kind of gets all over the gym. So in addition to volatilizing and getting into the air and distributing around the gym that way, it also, there's this very prolific dust in the gym because of this surface area combined with the photodegradation. So I did a study, recruited collegiate gymnasts from one collegiate gym in the US. We had a sample size of about 10. So despite the small sample size, what you can see is that this is the geometric mean concentration that of BDE 153 that we measured in the gymnast serum. This concentration was 4 to 6 times higher than the general population and similar to a population of foam cutters and carpet installers. This is on the log scale here. We also did a convenience sample of pit cubes from gyms across the US, and we found that 89% contain flame retardants. And we see similar a pattern of more pit cubes containing penta-BD before the phase out, and then more of these replacements after the phase out. So to communicate this with the gymnastics community, I founded the Gymnast Flame Retardant Collaborative. And there's a lot more to this story. You can go to our website and find out more if you're interested. For example, I've been working with a fire protection engineer to sort of on the same question: how do you maintain fire safety without the use of flame retardants in a gymnastics environment? So in terms of health effects, I'm switch gears a little bit now. Flame retardants are known to act on the hypothalamic pituitary thyroid axis. This is particularly true for the PBDEs. There's animal studies showing this for some of the replacements as well. And thyroid hormone is very important in neurodevelopment, in reproduction, and fertility. So here are some studies highlighting those for the replacements. And I think, as was mentioned in the last call, or the last webinar, TDCI-PP or chlorinated tris is a potential carcinogen. It's considered a potential carcinogen by the state of California. So for the past 3 years during my postdoc at Harvard, I've been looking at flame retardants in fertility. And to do this, we use a preconception cohort study design with an infertility clinic population. This is the Environment and Reproductive Health Study. Russ Hauser is the PI of this study. And we work with this population because it has a number of benefits in terms of looking at fertility, where we use it as a model of reproduction to look at fertility. So one of the benefits is we're able to measure exposure preconception. This is during the period that both of the gametes are developing, just prior to conception. We're able to include infertile couples who may be more susceptible to the effects of these chemicals. We're able to include the male partner. It's often hard to get male partners to contribute samples. And as we know, for fertility, the male partner is also important. And we're able to measure early developmental endpoints like oocyte count, fertilization success, implantation success. All right, so these are actually unpublished findings, but this is showing that the levels of the organophosphate flame retardant urinary metabolites are higher in the women compared to the men. For BDCI-PP, this is the metabolite of TDCI-PP, DPHP, which is the metabolite of TPHP, or triphenyl phosphate, and IPPP, which is IPPP, which is the metabolite of mono-ITP, which is part of the FireMaster. These two are part of the FireMaster 550 mixture. Can also be used as plasticizers. So some predictors, we found that these metabolites, some of these metabolites decrease with age. The TDCI-PP metabolite increased with BMI. They varied with time, so some increased or decreased by year. They tended in general to be higher in the summer and lower in the winter. They were weakly to moderately correlated with one another, and they were moderately reproducible across months with somewhat better reproducibility within a week. So here we're looking at implantations, the proportion of cycles resulting in successful implantation, clinical pregnancy, and live birth for increasing quartiles of urinary, the molar sum of the organophosphate flame retardant urinary metabolites, so going from lowest to highest exposure levels. And what we see is statistically significant negative trend. So this is 31% decline from the first to fourth quartile, and this P trend is significant, 41% decline and a 38% decline. And when we look at the individual urinary metabolites, we see that this is somewhat attenuated. It's probably strongest in DPHP compared to the other two, but then again is stronger for the sum of the PFRs, which suggests there may be some cumulative effect of these PFRs. And just to highlight that these findings are clinically relevant, this was an 18% decline in the adjusted difference of the proportion of live births. And usually when I give this presentation, I talk about the infertility epidemic that we're in. 10 to 15% of couples worldwide are infertile, with even more suffering pregnancy loss. And just last summer, a study came out looking at sperm counts or semen parameters over the past 40 years and found that there was about a 50% decline. So just to highlight why this is one of the reasons that this is important, that the PFRs may be contributing, or maybe one of many factors that are contributing to infertility. So here's sort of a summary slide looking at so in the green I'm showing where there was a statistically significant association, and the gray I'm showing where it was suggestive. And we can see sort of across fertilization, implantation, pregnancy, and live birth, these results were pretty consistent. Interestingly, for oocyte count, we found a positive association between the urinary metabolite of TDCI-PP and the number of oocytes retrieved in a cycle. And this was sort of surprising to me. And then when I went and did the literature review, there aren't that many animal studies, but one of them showed a similar result. So in zebrafish, finding a promotion of oocyte maturation, but a reduction in egg quality, reduced spermiation, and decreased fecundity. And a small study of adult men found decreased sperm motility with increasing urinary, I think it was TDCI-PP. So often when I present this, people want to know some tips for reducing their exposure. So sort of my top suggestion is really that these are difficult to avoid. We don't often have control over the chemicals in our indoor environment. And so, policy-wide programs are very important, like EPA Safer Choice. You can try to opt for flame retardant-free products. GreenSciencePolicy.org has some useful information. You can avoid installing carpet padding that uses recycled foam. This may help reduce exposures in your home. And washing your hands before eating, and for gymnasts after practice. And do I have a minute to go into this? Anybody know?
You're running about 5 minutes late, but I think you're close. So why don't you just do it?
Okay, so I think last week Tom probably talked about this, but just to highlight that the perfluoroalkyl substances, the PFASs, are another example of regrettable substitution, in that the PFOA and PFOS have been phased out of use, so they've been replaced with other PFASs, which we're beginning to get studies back on. So this was a publication that I co-authored last year, reporting on sort of the extent of PFAS drinking water contamination in the US. And these data are incomplete because this monitoring program had a size requirement. And so there's a lot of, if a town was too small or people on private wells, they were not captured by this monitoring. So I guess I'll leave it there. Just want to thank my mentors at the Boston University School of Public Health and collaborators, analytical chemists at the CDC, Duke. I've collaborated a lot with Heather Stapleton, University of Birmingham, our study participants, funding from NIHS, and my postdoc mentor, Russ Hauser, and the Earth Study team, and our collaborators at University of Michigan and Duke, and the Earth Study participants. And I thank you all for your attention.
Great, thank you. Maria, I don't have access to the questions that have come in. Can you read some of those out? And we have a couple of minutes where we could talk about those.
Certainly. So there's a question that has come in for Laura. Is Laura checking for gestational diabetes or blood glucose levels in the mother?
So that question came from Sarah Howard. So thank you, Sarah. It's a great question / suggestion. We have bloods banked from these moms, so we certainly could go back and look. And we have, in the case of the study I just told you about, all of those samples were collected at the end of the experiment, so we could easily go and go back and look to see if blood glucose levels are different. Usually, though, you have to fast mice in order to get good measures for blood glucose, and you don't really want to fast an animal that's also nursing. So I think a new study would need to be done to address that. But the point is well taken also, because some of the best work that's shown that the mother is affected came from Angel Nadal's lab in Spain. And he showed that BPA was not just inducing diabetes in the male offspring of mice that were exposed when they were in the womb, but also in their mothers many months after exposures ended. So potentially the alterations to metabolism are good sensitive endpoints for these chemicals, and potentially also are markers of exposure long after exposures end. So thank you.
Thank you, Laura. And then we have a question here that is for Courtney. How does the latest decision on flame retardants by the Consumer Product Safety Commission affect the chemicals discussed?
So I think it's helpful, right? The CPSC put out a statement, I think, was it cautioning consumers to avoid these chemicals? Does anybody, do you know?
I think some of them are actually being banned.
Okay.
But I don't know which ones, because I don't
Right.
work, yeah.
Yeah, I'd have to look more closely at the details. I think I only read the press release on it.
Okay, great. And then a question, I think, for both of you. What can women do before conception to ensure a clean environment?
So I think the clean environment thing, I assume you're talking about the environment of the womb, but maybe that's also a broader point about a clean environment. So there are simple things that that everyone can do to try to reduce their exposures to chemicals. So, you know, I grew up in a house where my mom used vinegar and baking soda and lemon juice as a major way of cleaning our house. She did it because it was a lot cheaper than cleaning products, but it works and it reduces chemical exposures. So everyone can sort of think about what are they choosing to use on their bodies, in their homes. You know, can I replace a canned food for something that's a fresh or a frozen? But for me, what I always sort of point out is that you can't avoid all of these chemicals, right? They're, as Courtney just talked about, they're in your work environment, they're in home environments, they're in places that we use for recreation. So in my opinion, putting all of the burden on women to avoid chemicals during or pre-pregnancy is putting the burden in the wrong place, and that instead we need to change how we evaluate chemicals for safety and push decision makers to do a better job with chemical screening before things hit the market. That's sort of my viewpoint.
Right, because it also creates disparities, right? If people feel like they can buy their way out, which might be more of a feeling than a reality at this point,
Right.
it can also leave others behind who can't afford to do that or don't have the knowledge to do so.
Great, thank you. So that's a great segue into this other question. Are the regulations against these chemicals more stringent in Europe, the UK, Asia, or Latin America?
So for the bisphenols, BPA itself is regulated more stringently in Europe than in the US. And so I believe in Sweden, they've just banned the use of BPA in products that are geared towards children 3 and younger. I don't know if that's more wide, if it's wider than Sweden. People often have the mistaken idea that BPA is banned in Europe, and that's actually, it's not true. It's not banned. It's regulated in certain uses. I'm not sure about the flame retardants. Do you know, Courtney?
So the PBDEs were used less extensively in the EU. They relied more on HBCD. So we actually see higher levels of PBDEs in Americans and higher levels of HBCD and folks in the UK, for example. A lot of production has actually moved to China. So that sort of lagged behind when the PBDEs are phased out here, production increased in China. So even though we phased them out, you know, they're still being produced. I don't know, I know that we did get some samples from gyms in the EU that turned out to be free of flame retardants for the pit cubes. So I thought that was maybe encouraging. But yeah, use patterns tend to differ internationally. And I'm not an expert on the policies.
Okay, great. So I'm just going to ask one more question and then I'll hand it back to you, Dick. So here's
Okay.
a question for Laura. Is the amount you expose the mice to comparable to human level exposures?
It's a great question and important when we're talking about environmental chemicals, and it depends on how you think about human exposure levels. If you're talking about how much we think humans take in, then the amounts that we're exposing our animals to are about 10 times higher than that. But mice metabolize chemicals faster, so considering, and differently. So they're chemicals that are usually excreted in the urine of people, like BPA, are excreted more in feces in animals. So if you're trying to compare urine levels, you have to give a mouse a whole lot more than you would give a human to get the same levels. So we're trying to get close to what we think people are exposed to. BPS is unfortunately not really well studied in human populations yet, so we don't know the true range of BPS levels in people. So far, the best studies have been done with kind of convenience samples that are looking at a few hundred samples that the CDC collected for other purposes. And I know that people are really interested in how we measure these levels. It depends on what the compound is. So chemicals that are more water soluble, we normally measure them in people in urine. But chemicals that are more fat soluble, we usually measure in people in blood or in some of the work that Courtney talked about in breast milk.
All right, thank you so much. So we are running a little late, but Dick, we would welcome some of your commentary. I think it's okay to take a few more minutes.
Okay. I mean, my main commentary is the future is in good hands with young stars like these two who are doing, I would say, cutting edge research on the chemicals of concern, the emerging chemicals of concern that the people in the CHE network are worried about. And we have two competent young researchers, pioneers under 40, so to speak, who are pushing that work forward. So I really want to thank them for their work and thank them for their presentations. They're both really outstanding young professionals, and it's a pleasure to hear them talk and watch their careers grow.
Thank you very much, Dick. So we are approaching the end of our webinar today. A video recording of this webinar will be available on the CHE website soon. Tomorrow you will receive an email containing a link to the video. CHE's next partnership call, hosted by the CHE Alaska Partnership, will take place Wednesday, November 8th, and is titled The Social and Scientific Discovery of a Class of Emerging Contaminants, Per and Polyfluorinated Chemicals. CHE's next partnership webinar in our 20 Pioneers Under 40 in Environmental Public Health series will take place the following day, Thursday, November 9th, and is titled Leveraging Open Data to Promote Environmental Health, Innovative Applications in Climate Change and Agriculture. To learn more and to RSVP, please visit our website at healthandenvironment.org. If you are new to CHE and would like to stay updated about upcoming events and more, please sign up to receive our newsletter by selecting the Join tab at the top of any page on our website. Additionally, if you appreciate these CHE partnership webinars, bringing you the latest environmental health research for free, we encourage you to support CHE's ongoing work by making a tax-deductible donation via our secure website. Again, our website is healthandenvironment.org. With that, I would like to thank our speakers once more for taking the time to present today and Dick for his moderation. Thank you for joining us and have a great day. Thank you, Courtney. Thank you, Laura. Thank you, Dick.
That was great.
Yeah, thank you.
Thank you.
Thanks. Bye.
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 Bye.